Now that you have finished reading chapter 1, let's go through and review some of the major topics in this chapter, the first being philosophies of science. Philosophy may seem abstract, but in fact, we should stop and think about why do we do research the way we do it? What is it about our collection of data and how we analyze data that allows us to better understand our world and ultimately to better control our environment? That's what this is all about. This is not some abstract pie in the sky. We should think about why we do what we do. There are various ways of conducting research. Scientific research and scientific method is just one of those ways. So let's take a few moments to review what you read, to sort of step back and look at the big picture, see if we can pull out the major features of these philosophies of science and how they apply to experimental design and analysis. Aristotle is often considered the father of science. In Aristotle's world, the predominant mode of logic was deduction. That is, using known ideas to obtain new facts. Aristotle's observations really were systematic classification based upon surface features. For example, a rock was something that was hard. A leaf was something that wafted to the ground. And then relationships were observations that things happened at the same time. Cloudy days produced rain. At the time, when Aristotle was in the midst of a society which simply attributed everything that happened to the gods, this was pretty profound to actually classify these observations. Francis Bacon moved away from the idea of deduction as the primary method of knowing. He didn't want to simply look at science as us figuring things out logically. He thought that what we should be doing is looking at the world as carefully as we could through an unbiased lens and do empirical study and experimentation to determine what patterns we could find. And this idea of patterns led to the notion of induction, the process of reasoning from the particular to the general. Birds have feathers is a universal claim that originated in noticing that many different species of birds had feathers. Bacon was all about rational thought that was unbiased, that the scientist was apart from the observation and making these experiments in order to come up with truth without influencing that truth. Galileo actually returned us to incorporating deduction back into the experimental process by saying that we don't just look at observables. What we're really interested in are not what we can see, but rather universal laws, something that goes beyond surface features. If you think of ideas like, for instance, acceleration, that is a construct. You don't observe acceleration. You can observe things accelerating, but the whole idea of us talking about them as accelerating is because we invented this idea based upon our observations. We invented this construct. Today, of course, we use many, many constructs, including in the behavioral and social sciences, things like aptitude and achievement and self-esteem are all constructs, scientific inventions that really we want to know how those constructs, those things we relate or made up in order to explain a group of behaviors, how they relate to one another. And we're looking for universals. We're looking for being able to make statements about these constructs that hold beyond the specific. And so that's where theory comes in. Theory is the idea of explaining and predicting phenomena, not just saying that something happens, but saying why it happens, trying to reveal cause and effect. The criticisms of these philosophies of so-called traditional science are many, and the authors of your book discuss a few of them. Pure objectivity is a myth. That is, we can't be totally objective. We have pre-existing ideas. The mere idea that we're looking at some phenomena is because we think something's going to happen or that there's something important about it. So it helps us determine the relative factors of our study. And the way that we detect patterns depends upon what we look at and how we analyze our data. The logic of discovery does not exist. That is, inductions don't reveal explanations, and theories are products of thought. That is, you do not see an observation and therefore you have a theory, but rather theory is something that we construct as a means of explaining it. It's not consistent with Bacon's, well, we're going to be objective external reviewers of nature, and from that we're going to have our explanations of how nature works. We have to, in fact, overlay what we observe with our thinking about how things work. Complete proof is unattainable. That is, evidence depends upon perception, which can be fallible. And even when we have a theory that seems to make a good explanation, how do we verify that that theory is correct? Well, the best we can do is see if it makes correct predictions. But theories making correct predictions doesn't mean that the theory's explanation is necessarily correct, because you could have an alternative theory that would make the same prediction. Science is based on critical assumptions. We assume the lawfulness of nature, and we assume that there is finite causation. The idea of finite causation is important because if we do not accept finite causation, we cannot accept generalization. That is, everything could be seen as being a specific instance, with nothing being generalized. So science is based on having these critical assumptions, and the key here is they're assumptions. We assume that nature follows a particular lawful pattern, and we assume that there are general principles and laws, and that we simply don't have specific instances in every observation that we make. Turning to more modern philosophies of science, the first one is positivism. Positivism was made very popular by individuals within the Vienna Circle, some of which are noted here. And the philosophy was that all that would be accepted as truth is that which could be completely verified. The central doctrine is the verifiability criterion of meaning. A proposition is meaningful only if it can be empirically verified. So therefore, if you notice that there was a relation of things in constructs in psychology, if we notice that self-esteem is related to motivation, that would not fit under positivism, because self-esteem is a construction. It's not something that is directly observable and totally empirically verified. So all we would notice are what individuals do and how they act, and talk about the relationships of those things, not that one causes the other, because the only thing that you can know are observables. A very restricted view based on the idea that science is simply going to be totally confirmable, totally verifiable. We turn from that to Popper, who came up with the idea of falsificationism that we still use widely today. This idea is that deduction is used to obtain knowledge when data are observed that falsify the theory under test. That is, we can create theories. We don't have to stick with just observables, but those theories need to be able to make predictions that we can observe, and if we don't observe them, the theory is incorrect. The little mathematical symbolism here means A implies B, not B, therefore not A. So if we say it is raining, that implies there are clouds. Well, then if you don't observe clouds, you can say it's not raining. So what we do with falsificationism is we build theories that we then use to create hypotheses about what will happen under certain conditions if the theory is true. Then we test under those conditions, and if we don't observe what we thought we should observe, we say the theory has a problem. So we extend beyond the idea of the only thing that you can show or prove is what you can observe, to an idea that you can actually live with constructs and cause and effect that lie beneath what we observe, if you're willing to falsify that theory based upon our observations. Now, Lakatos came along and tweaked Popper's philosophy and made it much more usable, saying that you don't just throw out a theory just because you have a disconfirming test. You wait until you have another theory that does a better job of predicting than the original theory. So what Lakatos was saying was, if every time we find a observation that's inconsistent with what we predicted, we throw out the theory, we'll end up with nothing. We'll end up with no theories, because we can almost always find an instance in which the theory doesn't seem to work the way we expected it would. So what Lakatos said is that he kind of tweaked the idea of falsificationism to say it's not so much that you come up with a single observation to falsify, but rather it sends you seeking for a revision of the theory or a different theory that actually does explain more, that works more often than the previous theory, and you replace theories. And by so doing, you gradually build your scientific knowledge by creating this framework that gets better and better and better as you get theories that stand up to more and more observational tests. Kuhn came along and said, it doesn't work that way. Knowledge is defined by the observer. Theories are constructs, and there are no external absolutes. Every observer might see something different. And in fact, normal science is just a social phenomena of shifting and competing paradigms that respond to what scientists embrace rather than successfully getting closer to the truth. So this led to splits in science in which some interpretations of science were totally willing to accept the idea of no external absolute, that you simply are embracing what seems to work. Probably a clearest and most powerful example of that is the Copenhagen interpretation in physics, which said that we have competing theories of the nature of electromagnetic radiation, one that says it's particles, one that says it's waves, and these are in conflict with one another. That is, you can't have both waves and particles. And what the Copenhagen interpretation stated was that when the wave theory worked, you use that one. When the particle theory worked, use that one. In other words, use what works. And you're not thinking in terms of what's true, but you're thinking in terms of what actually works. And so that's this relativist philosophy. More recently, there are some pushbacks against the relative philosophy, and this philosophy is one of realism. And realism starts with the proposition that there is an external world that exists independent of observers. It is not simply the fact that we each might see something different that leads us to say that it's observer dependent, but rather it's what lens we're looking through. An external world still exists, and scientific propositions still are true and false. They're not true under one condition and false under another. Theories are refined by rigorous testing that successfully approaches the true nature of reality. And the idea of relativist thought and realism thought still exists today, and you can still find proponents of research paradigms that exist, that coexist even under both of these different philosophies. I'm looking forward to talking more about our reading and seeing what you have to say and what philosophy you tend to lean towards, what your philosophical bent happens to be, and we'll do that in our session soon.